Hi, everyone. So now we define the two concepts, the annuity immediate and annuity due. So first, the definition of annuity immediate. So the annuity immediate is the following cash flow that is okay. So we have the time point 0 to n. And the cash flow is 1 each. So this is year, and $1 each for each year, starting at time 1. So this is the annuity immediate. So why we say annuity immediate? Because the accumulated value at time n. So the accumulated value is paid at the time n. So in an annuity, if you pay $1 for n years, then you received the lump sum amount at time n. So the accumulated value is paid immediate after the last payment, actually at the same time as the last payment. So that's why that we say this as annuity immediate. Yeah, and the present value of this annuity is called the A right angle n. So A right angle n is the present value of annuity immediate. A right angle n is defined as present value of annuity immediate. So we want to develop a formula for this. So okay, so $1, for example, the $1 at time 1, this is worth $V at time 0. And this $1 is worth the V square at time 0, because the V square becomes V after 1 year, then 1 after 2 years. So that means the present value of annuity immediate is V plus V square plus up to V to the nth power. So this is the summation of geometric sequence. So this is actually equal to V times 1 minus V to the nth power divided by 1 minus V. But the V over 1 minus V is actually the 1 over I. So, or we can say that this is 1 minus Vn over 1 minus V over V. And this denominator is I. So this is equal to 1 minus Vn over I. So this is the formula for a right angle n. And here we have used that the 1 minus V over V is equal to I. And actually, this can be verified by just some algebra. 1 minus Vi, V is 1 over 1 plus I. And just to make the same denominator, 1 is 1 plus I over 1 plus I, then divided by V, and V is 1 over 1 minus 1 plus I. Okay, so the entire numerator is equal to actually the 1 plus I minus 1 over 1 plus I. So that is I. Yep, I. Then denominator is 1 plus I. So you can see that this I 1 plus I cancel. So this is I. So that justifies the last equality of the last equation. Yeah, and here annual effective rate is I. Annual effective interest rate is constant I. So if we would like to clarify the interest rate is I, then we can write a right angle n I if we want to clarify I. Yeah. So this is the definition of the a right angle n and a right angle ni. And sometimes we want to calculate the accumulated value of AN. So that means we don't have this cash flow, but that we receive the accumulated amount. And that is written as S right angle N. So the definition of S right angle N is the accumulated value. So S right angle N is defined by the accumulated value of annuity immediate of N years. Yeah, annuity immediate for 1 year, N years. Then actually, if we have the formula for A right angle N, the formula for S right angle N is not difficult because we have just N year difference. N year difference means that we have to multiply 1 plus I to the power N because annual effective rate is I. So that means the Sn is equal to the 1 plus I to the power N times A right angle N. So that means this is equal to, okay, so 1 plus I to the nth power times 1 minus Vn over I. And actually the V is 1 over 1 plus I. So Vn, V to the power n is actually 1 plus I to the power negative n. Okay. So that means this quantity becomes 1 plus I to the nth power minus 1 over I. Okay, so V to the nth power is 1 plus I to the power negative n. So it cancels with the first term. So this becomes this. So actually the formula for Sn may be slightly easier, simpler than formula for A right angle N. So we defined the annuity immediate and the present value and the accumulated value of annuity immediate as AN and SN.